our first piece of given information. Okay, so we have a lot going on. For this particular situation, let's go ahead and list out what's given to us. All right, so we are being given, and based on our numbers, I see that we have angle 1. So this angle given here is, we're going to call him angle 2 because that's going to match up with our sequence. But we also have these two lines. And these two lines have this little red flags on them. The little red flags tell us that we have parallel lines. Okay, so in geometry we have lots of little notations. And again, it's the little red flags that I'm looking at right here that tell me that we have parallel lines. All right, so we have the two lines are parallel. So now we know that we have some specific properties that are going to apply to these angles that are formed. All right, so if those are the two lines that are parallel, then we also have this third line that is known as a transversal. The transversal transverses or crosses over the two parallel lines. All right, so now with that situation, we have all of these angles that are formed. Okay, and so like I said, we're going to say that the measure of angle 2 is equal to 89 degrees. All right, and what I want to do is I want to find the measurements of some of the other angles, but at the same time we're going to identify and define why is it that we know that those angles are equal to the value that we assign them. All right, for starters, let's look at vertical angles. Okay, because we have some of those going on here. All right, so if we look at this angle 2 that we've identified here, we should recognize immediately that angle 3 is a vertical angle to angle 2. And since that would be the case, angle 2 is congruent to angle 3. We also know that if angle 2 is 89 degrees, then the measurement of angle 3 is also 89 degrees. And that is by the definition of a vertical angle. Okay. Now to find the measurements of 1 and 4. We should also recognize that we have linear pairs. We could start with maybe, since we're given angle 2, we'll just start with angle 2 and identify it with angle 1. So again, angle 2 is 89. Let's find angle 1. So angle 1 and angle 2 are a linear pair. And in order to be a linear pair, they must be adjacent, and these two angles are adjacent, and also have that common vertex that forms an opposite ray or a straight angle. So we also should know that a linear pair is also supplementary. And so if it's supplementary, then it is also going to be equal to 180 when we add them together. So angle 1 is what we're looking for. Angle 2 was 89. Subtract the 89. So we find that angle 1 is equal to 91. Okay, so write that in here. All right, so what we should also recognize almost immediately is that not only do we have angle 1 equal to 91, but angle 1 is vertical to angle 4. So that would mean, by definitions of vertical angles, that we have angle 1 is congruent to angle 4. So therefore, angle 4 equals 91. All right, so that got us the 4 angles on that particular set. But the next question is, what if they ask us to identify angle 8? Okay, so let's just think about that for a minute. So now we're wanting to find a set of values on a different line. But there is a relationship between, let's say, if we wanted to find angle 8 here with our angles 1, 2, 3, and 4 that we just discovered. All right, so let's look at that. So we can look at maybe the relationship of, let's say, 4 and 8. So angle 4 and angle 8 are what we would call corresponding. Sometimes they're called same side. Oops, same side. But they're not inside. They're not interior or exterior. You'll notice there was one here that's on the outside. So like 8 is on the exterior of our two lines, whereas 4 is inside. He's between the two parallel lines. Okay, but they're known as corresponding angles. So if we already know that angle 4 is 91 degrees, and we know that these two lines are parallel, then we should be able to determine that angle 8 is congruent to angle 4. Okay, and that's again the definition. If you have parallel lines, all right, so we have been given parallel lines, then we can say that corresponding angles of parallel lines are congruent. So angle 8 and angle 4 have the same measurement. So then angle 8 is going to also equal 91 degrees. Okay. We could also move on around. We could say, okay, well, we know angle 2 has a relationship with 7, and that's actually known as an alternate exterior. And again, they're outside of the parallel lines. Both angle 2 and angle 7 are on the outside sections of our parallel lines. So angle 2 and angle 7 are alternate exterior angles. Okay, and of course we want to say, why are they alternate? Well, let's think about it. We have a transversal, right? We have this transversal that's running down, crossing over our two parallel lines. And we can see that 2 and 7 are on the outside of these two parallel lines. But you'll also notice they alternate sides. Okay, so they're alternating sides, and that is where this alternate comes from. Okay, they alternate sides of our parallel, our transversal, but they're outside of the parallel lines. And what we know also by definition is that alternate exterior lines, when given parallel lines, they are also congruent. So angle 2 is congruent to angle 7 based on the definition of an alternate exterior angles. So if angle 2 is 89 degrees, then angle 7 is also 89 degrees. Okay, so not too bad so far. Now, we could go and say, okay, we also have vertical angles and we have linear pairs. Those are things we would use to prove that these types of topics are true. Okay, so the vertical and the linears, those things prove to us that we can, validate what we have. But I really want you to focus on this new terminology here. All right, so let's take a look at some of our additional angles here. So now we still need to find and determine the measurement of angle 5 and of angle 6. So now we're moving inside our two parallel lines. So let's look at some relationships here, okay? All right, so we had alternate exterior. What about alternate interior angles? So an alternate interior would be, for instance, angle 3, and he alternates the side of the transversal, but is inside the two parallel lines with angle 6. So we have angle 3 and angle 6. And based on the definition of alternate interior angles of parallel lines, that's a key thing. They have to have parallel lines for these definitions to be true. We can then say that angle 6 is equal to 89 degrees. And that is because, again, angles 3 and angle 6 are also congruent to each other. And we also have another set of alternate interior angles. We have angle 4 is an alternate interior with angle 5. And again, based on the definition, they are equal. Excuse me. All right. So angle 5 is equal to 91 degrees. All right, so there's also one other relationship we want to talk about. Because if you'll notice, what happens if you add up two interior sets? Okay, so let's think about that. Angle 3 plus angle 5. What would we get? I hope you could say 180 degrees. Okay? These are called consecutive interior. Also commonly known as same side interior. Interior. There we go. Okay, and consecutive interior angles are supplementary. Okay, so that's just a key thing. So now we have talked about corresponding angles. We've talked about alternate exterior, and alternate interior, and also consecutive interior angles.